In this video, I'm going to show you what are similar polygons, and the symbol for similar is this symbol right here. So there are two conditions for similar polygons. Condition number one is corresponding angles. And remember, corresponding means that they're in the same, relative same position. So corresponding angles will be congruent. That is condition number one. All corresponding angles should be congruent. And condition number two is the following. Corresponding. And once again, corresponding means that they are in the same relative position. So corresponding, and it will not be angles, but it will be sides. Are the keyword is proportional. Okay, what does proportion means? Proportion means the following. Proportion means you have an equation and you have fractions on both sides. So I can have A, E, C, D. Okay, so proportion is an equation with fractions on both sides. Okay, now these two have a special name, and those two are called the extreme values. Okay, so if I ask you what are the extreme values of the proportion, you say the answer will be A and D. Now, these two have special name too, and these are called the mean values. So if I ask you what are the mean values of the proportion, your answer will be B and C, or C and B. Okay. Now in math 1, your teacher used to call say you cross multiply. For us, that's called a cross product. Remember, product means you are multiplying, so that's similar to, very similar to cross multiplying. Okay. And what cross multiply says the following is the product of the mean, all extremes that be equal to the product of the mean. So the cross product for these proportions I'm giving you is the mean. The extremes are B and C, so the product of the extremes will be equal to the product of the means. The means will be A multiplied by D. Okay, that's what you need to know to do similar polygons. So I have some examples right here. Let us do example number one. And example number one is the following. State if the polygons are similar, and that's what they gave to us. Okay, so what I'm gonna do is the following. There are two conditions for similar polygons. Condition number one, and I'm going to abbreviate corresponding angles are congruent. Okay, so to do that, let me name this A, B, C, and D. So this polygon is named A, B, C, D. And this one, let me name it D, E, F, and G. So what I'm going to do is I'm going to use D because I know the measurement right here. So angle D corresponds to what angle over here? Okay, well, D is the lower left side, so on the lower left side will be angle G. And are they congruent? Well, this is 125 and this is 125. They have the same measurement. So they are congruent. Remember, congruent means they're having the same measurement. Okay. Now, pick another angle over here, any angle you want. Let me pick angle B. And angle B is the upper right triangle. Corresponding angle over here will be the upper right. That'll be angle E. Now, are they congruent? Well, I don't know because they didn't tell me the measurement. Okay. But these signs are telling me that I'm looking at a parallelogram. If you have a parallelogram, this angle will be congruent to this angle. So this angle will also be 125. Same right here, parallelogram. It is 125. This angle will be 125. So if you say they're 125, yes, they will be congruent. Now pick another triangle you want from here. Any triangle you want. Let me pick angle A. Now A is the upper left angle. Upper left angle right here will be angle D. Now, are they congruent? Well, if I knew the measurement, I could say yes, they're congruent, or no, they're not congruent. Okay. Now, this is a parallelogram. So this angle plus this angle should give you 180. So 125 plus something should give me 180. What is that something? That something is 55. So this angle right here will be 55. Same thing right here. This angle will be 55. So if they're 55, yes, they are the same, so they should be congruent. And lastly, I'm going to use the angle I have a new C. Angle C corresponds to angle F right here. Now, if this is 55, these are opposite angles, they should be congruent. So this is 55. This is 55. And yes, they are congruent because they're both 55. So first condition, yes, corresponding angles are congruent. Now, second condition is corresponding, and I'm going to abbreviate also corresponding, but that angles besides are proportional. Remember, proportional means you have a fraction equal to another fraction. Now, because there are 1, 2, 3, 4 sides, this will be 1, 2, 3, 4. Now, the way you do this is pick any side you want from the first polynomial. Any side you want. Let me pick A and D. Now, this AD corresponds to DG over here, and that is a mistake. It shouldn't be D, it should be, okay, no, the mistake is the following. The mistake that I have made is in the following. I use D twice, and that's the problem that I'm having. So what I'm gonna do is should be DEG, erase the D, EFG. Let's make this H. Now B corresponds to angle A, so this should be an H. So let's make this angle H. And I'm sorry, not A, and B3. Everything else is correct now. Now over here, pick any side you want from here. Let me pick side AD. Now AD is the left side, that corresponds to HG. Go back to this polygon, pick any side you want. Let me pick side BC. BC is the right side, that corresponds to EF. Now pick another side from this polygon. Let me pick AB. AB is the upper side, that corresponds to HE. And lastly, side DC, that is the lower side, that corresponds to GF. Now if you look at this, it looks very, very complicated, but all it's asking is for the length. So what is the length of AD? AD is 15, so I'm going to put 15 in here. Now, denominator, what is the side HG? HG will be 10, and that's equal to side BC. This is BC. That will be 15. And what is the length of EF? EF was right here, that will be 10. Now, AB is 15 again. HE will be 10. And this will be 15. And this will be 10. Now, they're equal. So they are proportional. So therefore, my answer will be the following. Polygons are similar. Okay. Now, if you want to write the similarity statement, you can say polygon and name the first one. For the first one, you pick any order you want. Okay, so let's say I'm sorry, not E, C. So that'd be C, D, A, B. So let's choose C, D, A, B. And that is similar to polygon. Now for the second one, you don't pick any order you want. You have to pick corresponding letters. So who corresponds to C? C is right here. F corresponds to that one. Now who corresponds to D? Here is D, is G. And then A will be H. And E and B will be E. Okay. This should be written this way, but I don't run a space, so it's F. What was this? D, G, that's G. Okay. So, I'm sorry, this should have been, it's hard to see it, but that should be G. So, this order should be in this way, but one polygon is similar to the other one. The first one, you get to choose whatever you want. The second one has to be corresponding letters. Now, you gotta be careful, because if you have, let's say 4/8 is equal to 20/40. Now, if I ask you, are they congruent? Are they congruent? Are they equal to each other? Some of you may say, no, they're not equal. They're different, okay? But if I take the 4 and I factor the 4, so if I do the 4, what can I multiply to give me 4? Can I use 1 or 4? The answer would be 2 and 2. Now, what can I factor? What can I multiply to give me 2? Can I use 1 or 2? These will be prime. So instead of 4, I'm going to put in 2 multiplied by 2. If you do the same thing for 8, you're going to get factors of 2 times 2 times 2. Do the same thing for 20, you're going to get 2 times 2 times 5. And do the same thing for 40, it'll be 2 times 2 times 2 times 5. Now here's the way you do it. If we have the same thing, same number on top and the bottom, you can cancel it. I can cancel a pair of 2's. I can cancel a pair of 2's. So what's left over is 2 in the denominator. There's nothing on top, so there should be a 1. Okay. Cancel the 2's. Cancel the 2's. Cancel the 5's. So the answer is 1 over 2 again. So once again, if you look at this, you say, you know what? They're not equal to each other. They're both different. But if you reduce a fraction, then they are equal. They are the same. Okay. So you gotta be careful. In this case, we got lucky because they were all the same. But in some problems, they're not the same. Okay. At first, they don't look the same, but when you reduce a fraction, you realize that they are the same. Okay. Now, next example is the following. Solve for x. The polygons in each pair are similar. Okay. Now, similar. They told me they're similar. So I know two things. I know the corresponding angles, and I'm going to abbreviate. Corresponding angles will be congruent. And second thing that I know is corresponding angles, abbreviate again, not angles but sides, are proportional. When solving a problem you don't know how to do it, put everything on the table and then figure out who can help you. Okay, corresponding angles are congruent. If you look at the drawing, they told me nothing about the angles. I didn't get X or 45 or nothing. No information here. So this one would not be able to help me. It won't. Okay. Now, corresponding sides are proportional. They gave me sides. There are 4 sides, so there should be 4 proportions. 1, 2, 3, 4. Now, I can tell you that this are useless. They will not be able to help you. How do I know that they're useless? They gave me no information on these 2 sides. So this one, I cannot use it. I cannot have information about 2 sides. So the way to do it is, I like to start with what I'm looking for, the X or the question mark. So I'm going to do question mark here. Now this question mark, this side corresponds to this over here. So 7 is to 5 as or equal. Give me another side from over here. 14. Now 14 is the bottom side that corresponds to 7. Now get the question mark by itself. So I'm going to multiply this by 5. Multiply this by, not actually. Let me use a cross product. Okay, the product with extremes. Extremes are question mark in 7. So you multiply these, you're going to get 7 multiplied by question mark. Now the product of the means, that'll be 5 multiplied by 14. Now how would I get the question mark by itself? Divide by 7 and weight it to one side, you must weight to the other side. The 7 cancels, so you have question mark is equal. Factor of 5 cannot be a factor that is by itself. Factor of 14, what can I multiply to give me 14? Can I use 1 of 14? 2 and 7. Factor of 2, can I use 1 or 2? Can do it, it's prime. Factor of 7, can I use 1 or 7? That is also prime. So the answer will be 2 multiplied by 7. 7 is prime. Now can I cancel anything? So the answer will be 5 times 2 will give you 10. That is the answer. So class, when I'm solving these problems is I put everything on the table, all the information that I know. Some of it will be useless to me, useful to me. Some of it cannot help me. Okay, and that is the answer. So I'm sorry, there's no X. Okay, but I found the missing sign. I found it to be 10. Okay, next example. Solve for X, the polygon each pair are similar. Okay, the trick to this problem is you really need to understand what this says. If you understand this, then you should be able to do the problem. Okay, this is a proportion. So a proportion is a fraction is equal to another fraction. So here's my equal. So this is a fraction. So that should be A to B. And this is other fraction. The way we read this, we don't say 1 colon 3. We say 1 2 3. 1 2 3. Now if you notice there's no X in here, I cannot solve for X. So what I need to do is I need another fraction, and that comes from my drawing. Go to polygon A and give me one of the sides. Polygon A, one of the sides will be 10. Go to polygon B and give me one of the sides. Polygon B, the other side will be 3x. Now do the cross product, do the extremes. Extremes will be 1 multiplied by 3x. And the mean will be 3 multiplied by 10. Those are the mean values. Now, If I want the x by itself, I should divide by 1 times 3. And when you do it to one side, you do it to the other side. The reason why I do that is because these, I want these to cancel. So the answer is x is equal to, if you have the same number on top and the bottom, you can cancel it. I can cancel 3's. So the answer is 10 over 1, but 10 over 1 is 10. So my x is 10. So as you can see, the key to this problem is understanding what this is, realizing that this is a ratio. Once you do that, you can solve the problem. Okay? So that is the idea of the concept behind similar polygons. Okay? Thank you very much.